So, how are you? Oh, good, thank you. I'm good too. Um, as you probably, what are you doing here? I thought you were gonna be gone. No, you're not gone. No, no, no. You please stay. Am I losing my mind? No, okay, that wasn't you. Wasn't you. Never mind. You're good. So, as you know, we have a test this week. So we're here to review, and I'm here to answer your questions if you have any. Because you've been studying very hard for this test, right? All right, hit me with some questions. Sure, we can do some of the circle stuff. Do you... Let me get on Canvas. So do you have a problem in mind on circles? Okay. So what does it say exactly? I'm not going to open it up yet. So a circle question. So what is that question? Mm-hmm. Equals negative? All right. So when I ask you to show that something is a circle and to state a center and all that, you have to be looking at the equation of the circle. And that one you need to know. You need to know what the equation of a circle is, which is that. Where the center of the circle is h comma k. So h and k determine where the circle is centered, and the radius is r, right? So that's the general equation of a circle. Now, when I throw something like that at you, and we've done that before, you have to make this equation right here look like the general equation of a circle. So we did something with that, right? What is that I have to do in order to make the given equation look like equation of a circle? What is that procedure that I have to perform? That's right. I need to complete the square. And I need to complete the square for y's and x's. Because if I complete the square, it's going to look like that. So, and this is a nice version of completing the square, because then we'll get to add numbers to both sides of the equation and so forth. So when I look at the x's, just looking at the x's, what do I need to add in order to complete the square for just x's? What do I need to add? 4. How do we get 4? Yeah, you take the number in front of x, you half it, and you square it, right? So I added 4 to the left-hand side of the equation. I'm going to add 4 to the right-hand side of the equation. And, well, you mean the x squared, right? If it does, it's probably not going to be a circle. Okay? Well, in any case, if we had, let's say, 5 in front of x squared, I would divide everything by 5. Okay?
But what if it was like a number that wasn't like throughout the whole?
Well, that's what I'm saying. It will not work with this question because then you'll get something else in front of y squared. But if this was a quadratic equation, then keep that question in mind and we'll talk about that. But it's not going to happen with the circles because it won't be a circle then. Well, you know.
I know I'm a circle, but it just happens when I do quadratic.
Well, yeah, well, let's wait till we get to quadratics and you ask me that question. But yeah, this is a good question. It will not happen with the circles. It will only happen with circles if I had a 5 here and a 5 there. Then it will be the same number. It will still be a circle. But if it's not,
So the x and the y.
yeah, that x squared and y squared got to have the same coefficient. Otherwise, it won't be a circle. It'll be like an ellipse of sorts. And we haven't talked about that, so I'm not going to ask anything like that. Okay, so the circle questions will not have any coefficients.
So you got 4.
You got to, because you have an equation. Remember when we did with functions, you had to keep it all on one side, so if you add 4, you subtract 4. But here we have a balance. Now, how do I complete the square on the y's? So plus 1, right? We take 2, we half it, and we square it. So we're adding 1 to both sides, right? So then x squared minus 4x plus 4 factors into x minus 2 squared. And y squared plus 2y plus 1 factors into y plus 1 squared, while the other side is 4. Is that okay? Yes, the radius is 2. What is the center? Very good. 2, negative 1. Choose the opposite signs because the formula of a circle has minuses in there already. So the center is 2, negative 1. The radius is just positive 2. We can even, yeah, so, well, both of them are. It's just here you have no idea whether that's a circle.
So if you can't make it into that one, then it's not a circle.
Yeah. So basically, if we'll come out with a number in front or something like that, or with a negative on that side, or a negative over here, it won't be a circle. You should be able to match that original equation perfectly. Parentheses squared, positive number, right? Because if you change the plus in the middle, it will not be a circle, build some kind of a hyperbola. If you throw coefficients, it will make it into ellipse. You don't have to. It's just, all I know that that's a positive number. That's all I need, right? Because r squared is positive. And so if that side was 7, then the radius would be square root of 7.
Can they give us equations like that and ask us if they're circles?
Well, I don't see why not. Seems like a very reasonable problem, right? Potentially, sure. Can you grab that circle? Right, all you need is the center and the radius, so I can do it very easily. So it's 1, 2, minus 1, right? So that's the center, and the radius is 2, so it's actually going to touch the y-axis, and it's going to look something like that, close enough. You see what I'm doing, right? Okay, so the radius is 2. I have all the M names somewhere. So any questions on that? So this is one of those instances when we complete the square. I think that's the first time when we ran into that, right? And we kept bumping into completing the square for a while, right? 3 times we bumped into squares. Good. Want to talk about solving quadratic equations by completing the square? Well, because that's how we define, right? But you can also think about this way, since remember all the transformations that we've studied when you shift the graphs? When we did the circles, we didn't know the transformations. Remember how if you subtract from x, you go to the right? And this is the same thing, you go up. So this is the same transformation. You take the circle center of the origin, and then you shift it. You shift it 2 to the right and 1 down. Well, because it's kind of the same thing. It's inside the function. Okay. Are you sure? Or quadratic equation while we're talking about completing the squares? We can totally do both, but do you want me to talk about it? Because you asked that question. All right. So, solving quadratic equations by completing the square. Now, unless you're specifically told to solve a quadratic equation by completing the square, you're probably not going to solve quadratic equation by completing the square. Remember I mentioned that? If it's a messed up equation, just use the quadratic formula. But solving quadratic equations by completing the square so the worst case scenario is when you have a constant in front of the x squared, and then maybe another odd number in front of x, so that's already very miserable. And let's say, I don't know, 13. So this is, I'm just being nasty. Okay? If I give you an equation like that and just say solve, you're just going to plug it in a quadratic formula and get your 2 answers. Okay? But if I say by completing the square, we have to get all dirty with that. So the first step when completing equations when solving equations by completing the square is to get rid of that coefficient, that 13, subtract 13 from both sides. So this is step 1, subtract 13 from both sides. So that will give us 3x squared minus 5x equals negative 13. Okay? Then you divide both sides by 3. Very good. So the next step would be to divide both sides by 3 because we don't want to have anything in front of x squared that messes us up when we're trying to complete the square. So if you divide both sides by 3, you'll end up with x squared minus 5 thirds x equals negative 13 thirds. Is that okay? So we have some really ugly, odd-looking fractions. Now we need to complete the square, so that's the third step. So we're going to do the same way we did it with circles. Because when you don't have anything in front of the square, we're going to take that constant in front of x, so it's 5 thirds. We're going to divide it by 2, so times... Yeah, negative. The only thing that negative does is, if it's a minus, it's going to end up with a minus in the parentheses. If it's a plus, it's going to end up with a plus in the parentheses. That's the only thing what that sign tells me, right? So in this case, I know it's going to end up with a minus inside the parentheses. But anyway, so you take the number in front of x, regardless of the sign, because you're going to square it anyways. You half it and you square it. Okay? So when you divide by 2, that just becomes 5/6 squared, right? 5 thirds divided by 2 is 5/6. So this is what you're adding to both sides. You're going to add 5/6 squared plus 5/6 squared. I'll square it eventually, yeah. But on the left, the reason why I wasn't squaring it on the left, because this 5/6, this number itself, is going to be in my parentheses. It's going to say x minus 5/6 squared. That's what you get when you try to factor that. It's always going to be like that. Whatever this number that you're squaring is going to end up in the parentheses. Now on the other side, I actually have to compute it and see what I get. Yeah. So that's what the left-hand side turns into, is a perfect square. While on the right, I have to go through the motions of finding the common denominator, adding the 2 fractions, and all that. So actually, I do have to square 5/6, so that's 25/36. Is that right? So how do I add those two? Why 9? Well, 3 times 9 is 27, right? So you want to multiply by 12, actually. It's 12 over 12. That's how you get to 36. So we get x minus 5, 6 squared equals, so denominator is 36. Now 12 times 13, 156, right? Someone said that. So it's, well, the LCD. So it's negative 156 plus 25. So that is negative 131, is it? Over 36? Is that right? Okay. So now when we got it to this point where I have a perfect square on the left and whatever the number on the right, I'm going to start taking square roots of both sides, square root of the square. The right-hand side is negative, so I know my answer is going to come out with ice and so forth. I'm not going to have any real answers here. But at this point, you're just going to start taking square roots of both sides. So that's x minus 5/6 equals plus or minus the square root of negative 131 over 36. So it's always plus or minus when you do the square root of both sides. Now, I'm going to try to simplify the right-hand side. I don't think I'll be able to take square root of 131 in any way or form. Will I? Probably not. That number. But I can take square root of 36. So denominator is 6, right? And the numerator, I can just say it's I square root of 131. So I'll take the negative out of the radical, turns into I. And then so for x, you just add 5/6 to both sides. So it's 5/6 plus or minus all that. So same denominator. So the answer is 5 plus or minus I square roots of 131 over 6. Because I took square root of it. It was under the radical. Well, because I was getting rid of the power 2. I was getting rid of the square, so that's why I square rooted. If you were getting rid of the square root, you would square. I don't see why not. What? Those are all good questions. You want it to be on the test? Sure, why not? We can do different. But yeah, if I say solve this equation, then use the quadratic formula. Don't go through this. But if I say solve the equation by completing the square, you have to go through all that. And this is as miserable as you get. This doesn't get any worse. Because all the numbers are odd, your fractions are ugly, and the other side is negative, so you have to remember about the I. This is the worst case scenario. Okay? So that's the good news, I guess, right? That doesn't get any worse than that. What? No, but just think what you're going for. Really, it's only 2 steps. Complete the square and then square root everything. Oh, yeah, don't make any little mistakes. That's true for no matter what I ask you to do. So, difference quotient, right? So far, you notice that you kind of need to know what the equation of a circle is. So that's kind of, you need to know that. When I say difference quotient, you need to know what that is. What? Why are you laughing every time I say something? I'm not being funny. Am I? Or is it one of those hysterical laughs? That's... No, I do not. I don't know. I might not listen. So, but you can probably find it online. What? What did you say?
He has candy.
Oh, you have candy? Is that what? Oh my God. You know me by now. I'm not that cheap. It is. Yeah, you're welcome. So difference quotient, you kind of need to know when I say difference quotient, this what should pop in your head, that that's a difference quotient. If that does not pop in your head automatically, just think that that's nothing but equation for a slope. It's change in y over change in x. That's what it is. That's how we came up with that. Change in y over change in x. Yeah, but it's you still need to know exactly what you know.
Can you write it another way?
No, this is the only way. Um, so now I usually give you a function, then I say find the difference quotient of this function. And what we agreed on is when we do those types of problems, you have to set it up and then simplify until that original h from denominator kind of cancels out. That was the deal we made. That's how you know that you're done simplifying. Yeah, well, there could be a new h in the denominator, but not that original h. So if you have a function, if I give you a function, something like that. So this is a nice examples when I give you something like that, quadratic, let's say, and I ask you find the difference quotient of that function. Really, the biggest thing is the setup. No, no. We haven't seen any more problems that involve difference quotient, so we just need to know how to set it up, simplify it, and when I say difference quotient, you need to be aware of what I'm talking about. All right. So again, so the difference quotient is this thing. So it has three parts. It has your function evaluated at x plus h. And we've done it a few times. We realize how the function notation works. Whatever you put inside the little parentheses takes place of your variable, right? So f of x plus h becomes negative 3 times x plus h squared plus 3 times x plus h minus 4. So this thing right here is f of x plus h. I'm not done setting this up, but the first thing we need to do is to figure out what f of x plus h is. That's that. Then the formula tells me subtract the original function, and you should put the original function in parentheses because I'm subtracting the entire function. So I'm going to toss a pair of parentheses and write the original function in them. So this is f of x. And everything over h. So that's the setup. You don't have to label it like that. I'm just showing you where it comes from. You just need to know how to set that up. The rest is just simple algebra, just opening up parentheses, combining like terms, canceling, reducing, and so forth. So really, this is the only new thing that you learn in this class, how to set it up. Okay? The rest, open up parentheses. So I need to square x plus h. How do you square x plus h?
X squared plus 2x.
Yeah, very good. X squared plus 2xh plus h squared. Shaq, what was your question? Yeah, because the original formula has a minus in between. That okay. So right, so that's how you square x plus h. If you still till this day don't know where that come from, write it x plus h, and FOIL. Okay. Um, but I'd rather you do it fast with the formulas. Now distribute. Well, I'll distribute 3 next.
If we do it on our test by not putting out 3, is that
Well, what did you do first? Did you distribute
like, what
3?
if I didn't distribute at the same time?
Well, did you get negative 3x squared minus 6xh minus 3h squared? Is that what you? Then that's fine. Yeah, that's okay.
If you write it
Yeah, if you do it right, then it's fine. Because I mean, the common mistake would be to distribute 3 and then square it. That's violation of order of operations. You're gonna get the wrong answer. But if you're comfortable of knocking 2 steps at one, hey, I'm okay with that. But more chances of making a little error. But anyways, distribute that other 3, so that's 3x plus 3h minus 4. Distribute the negative, becomes positive 3x squared, negative 3x, positive 4, all over h. Is that okay? So all I'm doing, just opening up parentheses, there's no new material. I can cross few things out. What can I cross out? Yeah, I'll distribute on the next step, but yeah, I can cross out the 4s, I can cross out the 3x's, and I'll distribute the negative 3. So when I do that, this is where I'm at. Just distribute negative 3, so I can cross out negative 3x squared with a positive 3x squared. Well, technically, yeah, you can just, if you just remember to cross out all the h's, almost. But the proper way to avoid making any silly errors would be to factor the h out of the numerator, so it's negative 6x minus 3h plus 3 all over h. And then you can kill the h's, and we're down to negative 6x minus 3h plus 3. Is that what you got? You did? Well, because you were distributing all at once. Because again, it's really hard to keep track of both, because you're trying to do 2 things at once. And you're going to be taking 7 more steps anyway, so what's the point of skipping one? So
Can you do? I don't understand how you figure out the domain of like f of g like when they're together.
yeah, don't worry about it. I'm not going to ask anything like that. Yeah, to be honest, yeah, that's just silly. It's. I'll ask you just the domain of a function. Yeah, but not, composition gets really tricky, and I don't want you to mess with that. No, because I'm probably, I certainly could do it wrong. What? Where? What are you talking about? Yeah. Yeah. So that was a plus 3h all along. And then I took the h out, so I still have a minus minus plus, right? Minus minus plus. You're skipping steps. Well, extracting the square root is everything from this step on. Like the previous example we did, when you have a perfect square equal a number, to extract the square root, you do plus or minus. So this is the extracting the square root. It's already given to you as a perfect square. So you isolate the perfect square and then square root both sides. Square root both sides. Yeah. So with the plus or minus. Did you find your minus? I could be wrong. I'm not saying that, but do you want me to find it?
So if you distribute this,
Mm-hmm. Mm-hmm. You're missing a 3 there, minus 3h squared, right? Yeah, and then solve for x. Right, so you add 1, divide by 2.
and then you have to do plus.
Yeah. on the radical. Other questions? Like that? No, you'll be asked to find the difference quotient of a function. So find the difference quotient of, and the function is. No, your answer is just that thing in the box. Your answer is not x equals anything. That's what the answer is.
After a good idea of like the types of questions that we have.
It's a brilliant idea. Yeah. I have
Yeah, to find the domain of something you just said is equal to 0.
well denominator. Why did you what? No, that's not right. That's crazy talk. What is the question? So find the domain. So x squared minus 16 over x squared. You cannot have 0 in the denominator. That's right. X squared plus x minus 6 cannot equal 0. Very good.
Do you set it equal to 0?
You can.
Say that the answers are not.
Yeah, the answers are not what the solution is. Another way is to just factor, right? This is the easiest thing to do. The numerator doesn't matter at all in this case, even though I can factor that numerator. It will make no difference in my domain. But how would you factor the denominator? X plus 3x minus 2. Two numbers that multiply to negative 6 and add to positive 1, or negative 2 and positive 3. And then you can clearly see what numbers make the denominator equal 0. What are they? Negative 3 and positive 2. So domain would be all real numbers except for negative 3. Sure, you can write it like that. You can make it this notation. It's all x's such that x cannot equal to negative 3, comma, positive 2. So that's fine. You can write it like that.
What's the other notation?
You can do the interval notation from negative infinity to negative 3, union from negative 3 to 2, union from 2 to infinity. If you write in English all real numbers except for positive 2 and negative 3 while spelling positive 2 and negative 3 with letters, I'll be happy. You can. But if somehow you know, communicate the truth to me, I'll be able to understand. Unless you want to score 100 on this test. If everything is perfect, you want to get 100, you better put one of them pretty answers. Yeah, well, if I say list it in the interval notation, you should list it in the interval notation. If I say list it as a set notation, you should list it as a set notation. The interval notation is this. This is the interval notation. This is the set notation. Because then you have this whole gap that's not included, right? Because then you're not including anything from negative 3 to 2, while I can use 0, 1, half, right? Because it's really its entire number line with just two holes in it. Just few little holes. Does that make sense? So that thing that you were doing, that's not good. Leaving that 6 on the other side. If you solve by factoring, you better have 0 on one end of the equation. Anything other than 0, solving by factoring just won't work. Because, you can multiply two numbers to get 6 infinitely many ways. But there's only one way to get 0 as a product when you multiply by 0.
Do you ever get like the curve parentheses like equals to like negative 2? Would that be like the opposite?
You can get that in the certain problems. It'll come up, right? If I give you like a square root problem, then because you can get 0 under the square root, so you might get a bracket. So you have to be very careful. You have to really understand what the question is asking you, and then just judge whether you need that number or not. And I'll tell you whether you put a parenthesis or a bracket. Yeah, go ahead.
What do you mean state the real and imaginary numbers?
state the real and imaginary parts. I'm sure it says. So you have to. No, just if you have a number that's like this, 2 minus 3i over 5. Okay? What is the real part? And the way I wrote it in class was like that. Real is 2/5. That's the real part. And imaginary part is negative 3/5. So if you write it like that, I'm okay. Yeah, the I is not part of that. So you can just write the real part is 2/5. I'll be okay with that. Again, you just communicate the truth. All right, well, then you have to make it pretty. If it's I on the bottom, so, I don't know, 6 minus 5i over I, right? In order to make that pretty, you have to rationalize, you have to do the division. You have to get rid of I out of the denominator. And one way to do that, remember what we agreed? What do you have to multiply by? Yeah, multiply by the complex conjugate. So technically, what is the complex conjugate of I? Negative I. So multiply top and the bottom by negative I. That's all right. Okay? So if you do it in the denominator, you'll get negative I squared. Right? What is I squared? So negative of that? No, the denominator is going to be positive 1. I squared is negative 1 times a minus, so it's a positive 1. While in the numerator, you're going to have negative 6i plus 5i squared. Right? So if I actually make it all pretty, denominator is 1. That's a good news. Very good. Because I squared is negative 1. So that actually comes out to be negative 5 minus 6i over 1. So negative 5 minus 6i. So what is the real part? And what is the imaginary part? Right. So real is negative 5. Imaginary is negative 6.
So with an imaginary number, though, always have one.
No, not 1 on the bottom, but a real number on the bottom, yes. Doesn't have to be 1 every time. Well, yeah, if that's what you want to do. Or just understand it, and then you don't need to memorize anything of it. Just understand. This is the same concept. You did the same stuff with the square roots. When you get rid of square roots out of the denominator, it's the same idea. So this is just another way to look at it. What I do what? Sure. So x to the 6th power plus 7x to the 3rd power minus 8. Does that say find all real solutions? Oh, good. So let's try that. So find, well, so basically solve it, right? So, that's a 6th-degree polynomial. We're not quite sure how to solve those, but what is the connection between powers 6 and 3? What is that relationship that they have? Yeah, or the other way, one is the square of another. So it looks like a quadratic equation? Sure. You're absolutely right. 3 is not the square of 6, but the power of 3 is. Yeah, so it works different with exponents. But yeah, so this is one of those equations of quadratic type. Yeah, 6 and 3, 8 and 4. It could actually work with things like, 5 and 5/2. As long as one number is a double of another, it will work. Okay? So we can do that. So this is an equation of a quadratic type. I'm not even going to make a substitution here. I'll do one where you have to make a substitution. But if this was a quadratic equation, forget about 6 and a 3, can you factor that? Yeah, you need two numbers that multiply to negative 8 and add to positive 7. What are those two numbers? Right, so those numbers are negative 1 and positive 8, right? So I'm just going to put x cubed up front. So it's actually going to work. That's how you factor that. It's, you know. All right. Well, this right there is a difference of two cubes. X cubed minus 1, I can factor that. Well, actually, if you just want to solve, so if you just want to find the real solutions, you don't have to do any more factoring. You just set them both equal to 0 and you solve. But if you want to find all the solutions, you have to do factoring. So the way to factor x cubed minus 1 is x minus 1 times x squared plus x plus 1. This is x cubed minus 1 factored using the difference of cubes formula. Now, on the other one, I can use sum of cubes formula. It will factor into x plus 2, and then x squared minus 2x plus 4 equals 0. I won't be able to. But those are quadratic. I can solve them by using quadratic formula. Right? But at this point, I have a product of 4 factors. And I can set all of those factors equal to 0. X minus 1 equals 0. X squared plus x plus 1 equals 0. X plus 2 equals 0. And x squared minus 2x plus 4 equals 0. Right? Each factor set it equal to 0. So x equals 1 and x equals negative 2. These are your real solutions. You're not going to get any more real solutions. Yeah. Now, in order to solve x squared plus x plus 1 equals 0, you have to use the quadratic formula. And when I plug it into the quadratic formula, negative b, so it's negative 1, plus or minus the square root of b squared, so that's 1, minus 4ac, well, everything is 1 here, so minus 4 over 2. The quadratic formula, right? So you end up with a negative 3 under the radical. So x equals negative 1 plus or minus I square root of 3 over 2. So these are two complex solutions with i's and all that. Yeah, there's nothing else I can do with that. And if I do the same thing with the last equation, again using the quadratic formula, negative b makes it positive 2, plus or minus the square root. B squared is 4, minus 4ac, so it's 4 times 1 times 4, over 2 times 1. Just quadratic formula, right? So 2 plus or minus the square root of 4 minus 16 over 2. And 4 minus 16 is what? Right, so 2 plus or minus square root of negative 12 over 2. Let me scroll it up a little. Well, not yet. I need to do some extra simplification. But eventually it will, but I have to be really careful. So how can I deal with the square root of 12? How do we take square root of 12? 2i, right? Because you're going to break 12 into 4 times 3. You take square root of 4, comes out as 2i square roots of 3 over 2. Now you can cancel all the deuces. 2, 2, and a 2 will all cancel. Because you have to make sure that that 2 divides both. So you'll end up with 1 plus or minus I square root of 3. Well, Yeah, if this was no 2 in front of the radical, then you won't be able to reduce it in that form. Yeah.
So you said the one and negative two are the real solutions. Are you gonna want all four, or
Well, I think the question was find the real solutions for extra credit, find the rest. So yeah, but this is how you get all of them. And by the way, do you see how we have 6 solutions? And usually that will happen with the 6th degree equations.
Like another one where we like substitute for you.
Well, 1, 2, 3, 4, 5, 6. Now again, remember your solutions. Yeah, your solutions with I and it always come with a friendly conjugate. If you get one solution with I, you always get its complex conjugate. So your complex solutions come in conjugate pairs always. Uh, what? Yeah, I'll do that one. Now, but before, so let's do another.
We don't really substitute.
Yeah. So I want to do something that's a little more messed up as far as what did that one say?
X to the power x cubed plus x times 1.
No, you're on your own there. Just factor by grouping. You don't need anything fancy. But yeah, I haven't decided yet. But let me do something that's with a hidden quadratic that's a little crazier. Um, well, then, then you're not going to make it, man. That's basically what's going on at this point. If you don't know how to factor by grouping, we're way past the point of no return. Um, I want to do another problem where you solve quadratic type, so equations of quadratic type. That's a little more messed up. And then we'll come back to do. I need to think of a good example. So, hmm. Well, we can. That's gonna get messy. But anyways, let's try this one. So let's say I have x cubed minus 2x to the power 3 halves minus, let's say, 8 equals 0. So this is still friendly. What? Just making one up as I go. So again, the relationship is when you notice that you have two exponents and one is the double of another, right? If you multiply 3 halves by 2, you're going to get 3. So that means you're looking at something that's sort of quadratic. Okay, so if you have that relationship with one power is the other power times 2. So the way we do those, we're going to make those little substitutions. We're going to say let u equal whatever exponent that's not squared. So let u equals x to the power 3 halves, something like that. Okay? So again, the relationship, in order to get from 3 halves to power 3, you have to square 3 halves to get to 3. So then when you make the substitution, you'll end up with u squared minus 2u minus 8 equals 0. That's all right, Jack. I'm not going to answer that question. But again, so when you see a pattern where one power is double of another, that means you're looking at a quadratic equation. You're looking at this thing of this form, where one power is the square of another. So this is called equation of a quadratic type. And the way we solve them, we make a little substitution first. We replace the part that's not squared with the newly invented dummy variable. You can call it whatever you like. So if you replace every x to the power 3 halves with a u, you're going to end up with a negative 2u. And this will become u squared. Because if you square 3 halves, you're going to get power 3. So that's a whole new equation which we're going to try to solve for u. So let's solve for u. How would you solve this equation just for u? Forget about everything else.
U minus 4.
Yeah, you will factor. So you say, okay, u minus 4 and u plus 2 equals 0. So that means u minus 4 equals 0 and u plus 2 equals 0. U equals 4, u equals negative 2. Okay?
So that X is.
That's right, because now we can substitute back. To solve for x, you need to substitute back. And you'll get x to the power 3 halves equals 4, and x to the power 3 halves equals negative 2. And then we're going to try to solve those two equations by, well, those two equations for x. That's exactly right. Very good. So what she's saying is that the power 3 halves is really square root of x cubed, like that. That's what really power 3 halves means. And it's really good if we remember that, because it will help us. Hmm? Mm-mm. On that side, yeah, on the right side, if you had a square equal a negative number, you'll be getting an I. But this is a square root equaling a negative number. Okay, so that will actually have no solutions. Are you right there? What's up? Oh, okay. Are you sure?
Very sure.
Okay, let me show you this. So it's a square root. How do we solve equations that involve square roots? Square it, right? So if I square both sides, I'll get x to the power 3 equals 4, right? And then what is x? You will take a cube root of both sides. So x is cube root of 4, right?
So no matter what, you can always square both sides or just substitute
What was the last word?
minus the dollar.
Yes. Then the answer to your question is yes.
Okay, so say 3 is the cube root.
Yeah, so 3 is the power, the numerator is the power, denominator is the radical. But anyways, if you go back, because what do we do when we square both sides? When we solve equations that involve square roots, what is the very last step we have to do every time? When you solve equations that involve square roots, you got your answer. What do you have to do in the end? Check it. If you go back, plug it in, it won't work. You're not going to get negative 2 for an answer. Okay, you're going to get positive 2 for an answer. So, but every time you have these equations, the square root of whatever equals a negative number, it will have no solution. Square roots cannot produce negative results. So all this stuff we didn't have to do. We just say no solutions. You cannot have a square root equaling a negative number. That's for the second one. So I didn't have to do any of that. I just knew that the square root cannot be negative. Because what is the graph of the square root function? Right? Doesn't do anything on the negative side. So that one has no solutions. This one, we would solve exact same way. We would square both sides. So x cubed equals 16. And then you would take a cube root. So cube root of 16. So whatever that number is, that will be the solution to our equation. I can simplify it a little bit further. Can I take a cube root of 16? No. But can you write 16 as a product of something that's pretty cubic? 8 times 2, right? Can you take a cube root of 8? Yeah, so it's 2 cube roots of 2. So that's the only solution to that equation. The big story here is the initial part. What 3? Yeah, that's a 3. I don't know. No, I don't know. No, the answer is no to that question. They're not worth 1 point and it's right or wrong. So it's in here. You're gonna show up here and it's gonna be, for those of you who take this class as a, for those of you who show up and sit at the desk, you're gonna come back here on Wednesday and take the test in class. Okay. So equations of quadratic type. Make sure you understand that concept of substitution. We've covered it in class. You've done a few homework problems on that. So factoring by grouping, is that what we need to discuss?
Yeah, we need to go back to the
What? You're just saying? Oh, okay. Do you have questions? That makes sense? Okay, good. So what's the factoring by grouping problem? And I will talk about defining the vertex. You're in line. Okay? I mean, I'll get to talking about the vertex. I know you asked that. Now you have to start from the beginning. What? All right. So factor by grouping. How do we factor by grouping? First two terms, what can you take out? X cubed. What does that leave you with? X minus 1. In order for this to work, you need another x minus 1. Do you have another x minus 1? Yes, so I can actually, if you want me to, I can put a parenthesis around x minus 1 just because I can. But the big message here is that x minus 1 is our common factor. So if I pull x minus 1 out, what is left? Plus 1. Right? And the other one is the sum of cubes, x cubed plus 1. Right? It's the sum of 2 cubes. I can factor it even further. Factoring the sum of cubes results in this. Right? That's the sum of cubes. So again, as before, set each factor to 0, and then solve. So x minus 1 equals 0, x plus 1 equals 0, and x squared minus x plus 1 equals 0. So x equals 1, x equals negative 1. What was that? Okay. And the last one, just plug it in the quadratic. It'll give you, again, the solutions with i's in it. Okay? If it's a part of the sum or difference of cubes formula, then yes. Okay, but see, that's another piece of information that'll just gonna clutter your brain. You don't need to know that. All you know, this is a quadratic equation, and I'm just gonna start solving it. If it shows up with an I, oh good. If it doesn't, even better. Okay, but don't try to pre-analyze. No, something important will fall out of your head, and then you just don't put that in, because you might lose something that matters.
Can I leave it like that?
Yeah, if I ask you to solve, then I want to see the answer. Don't tell me the solution to this equation is whatever solution to this equation is. That's what you're trying to tell me. But yeah, if you solve this, it'll come out to be 1 plus or minus I square root of 3 over 2. So it's same as we did before, only with the positive 1. One before was a negative 1.
Look, you just have the six. Just have the six when it's divided by
What are you talking about? Because I knew the solution to this equation right there. It's very similar. So that one had a -1, while this one will have the opposite. This one will start with a +1. But plug it in the quadratic formula and you'll get it. What was that? Here we go. All right, vertex. Of a parabola. You can certainly try.
2x squared minus 7x.
And so how do we find the vertex of a parabola? You have a one magical formula. Do not complete the square if you just have to find the vertex. It will be very messy. Very good. What is the vertex of a parabola? Right, the x value is -b/2a every time. Now the y value would be the value of your function at -b/2a, right? So that's about it to find the vertex. So the x would be -b/2a, so it's negative, what is b? -7, and 2a, it's 2 times 2. So +7/4. That will be the x value of the vertex, okay? That also would be that axis of symmetry. This is over which axis the parabola is symmetric. Yeah, we found the x value of the vertex, which is also our axis of symmetry. If you think about this, right? The parabola is symmetric with respect to its vertex. Now, how do we do the y value? Yeah, plug 7/4 into your function. So this will get a little ugly, but it's 2 times 7/4 squared minus 7 times 7/4 plus 4. So whatever that number comes out to be, that is the y value of the vertex. So it's 2 times 49/16 minus 49/4 plus 4. If you start computing that. What did you say?
Where did that 2 pop out?
I don't know which two you're talking about.
When you start your function 7/4.
Well, because the function has a 2 in it, right? Doesn't it? Function starts with a 2. Anywho, so if I keep reducing it, 2 and 16, that turns into 8, right? Is that right? So you just have to add few fractions. What would be the common denominator between 4 and 8? 8. So that's 49 minus, how do you turn the second fraction so it has 8 in the denominator? Multiply by 2, so what is that? 98. And how do you turn the last fraction so it has 8 in the denominator? 32. You multiply 4, right? It's 4/1. You multiply it by 8/8, so it's 32. So 49 minus 98 plus 32. What is that going to give us? No, I don't want to hear that. No, it's not. How is that easier?
It's -17/8.
Yeah, -17/8. That's your answer. If you're asked to put your answer in the decimal form, then it's yes. But technically, that's your answer right there. So, what is the vertex again? And does this, no, wait, does this parabola have a maximum or a minimum value? Minimum, how do we know that? Because the number in front of the explorer is positive. So what is that minimum value of that parabola? negative 17/8, right? So it's a normal parabola. So that's how you do the vertex. The axis of symmetry is whatever the x value of the vertex, right?
I don't see how it was axis.
Whatever the x value. So it's x equals 7/4. That will be the axis of symmetry. Right? The parabola is symmetric with respect to its vertex. So x equals 7/4 is axis of symmetry. Now, Shaq, what is your question?
Two times 49 or 16 to, if 8 is the lowest common denominator.
Yeah, I just added a few fractions there. Yeah, I just added those, made them all, because it cancels with the 16 and turns 16 into 8.
I don't really get 17. It's like, which sets of ordered pairs represent functions from A and B?
Okay, well, give me the two sets.
A is 1, 3, 5.
Okay. Hang on a second. So set A is what?
1, 3, 5.
And set B?
Negative 2, 3, 1.
And what is the set of ordered pairs?
1, 2 different scattering.
Okay, 1, 1.
Add 1, 3, 1.
What?
7, 2.
All right, forget about all this mumbo jumbo before. Is that a function? How do we know? All right, good. So that's a function. Right? So you're just looking for the repetition in the x. So this is a function. So what does that say? What are the ordered pairs?
The 1, negative 1, 1, 2, 1, negative 2, 4, 0.
Yeah, that's definitely not a function. The x value is repeating, so that's not a function.
How is that relevant to A and B?
Don't worry about it. It's just the question is function or not function. Okay?
And C is 1, negative 1, 0.
And I'll just ask you, here I'm not even going to start with A and B.
Wait, but there's another set to stop.
I don't know. So what is 1?
1, negative 1, 3, 0. Add 1.
Yeah, that looks like the almost one before. So yes, that's a function. Just look at the x values, and if there's no repetition, you got yourself a function. If I give you a graph, how do you know whether a graph represents a function? Yeah, so vertical line test. Very good. So explain. You just did, right? No repetition in the x, repetition in the x, and then no repetition in the x again. So that's why. Don't worry about it. Yes, but don't worry about it.
So, why? So when we get full credit on the test?
Yeah. Yeah. I'm not even going to bother with A and B. I'll just give you the sets of ordered pairs and ask you, is that a function?
Doesn't it make sense that you're telling us not to worry about it? This is part of the
Do you think I sat down and typed the test from scratch? I just piled a whole bunch of old crap on one file, so that old question from 3 years ago when that actually made a difference made it on there, so don't worry about it. Take my word from it. We used to have much higher standards 3 years ago. No, exam's going to be all right.
That would be really confusing.
Are you kidding, man? All right, go ahead. All right, so line passes through 311. And perpendicular to the x-axis, right? Is that the question? Okay. It's almost a trick question. Because again, No, you can find the equation of a line. It doesn't have a slope, right? But before we go on to, can you like sketch the graph of that line? Can you see what that line is? It passes through 311, so you know whatever the 311 is. Let's say it's here, 311, right? And that's perpendicular to the x-axis, perpendicular to the x-axis. So it has to go like that, right? That's what it looks like to be perpendicular to the x-axis. So is that, what kind of line is that? Well, the slope is undefined. It's a vertical line, right? So what did we agree? The equation's a vertical line. X equals whatever x equals. So it's x equals 3. So equation of this line is just x equals 3. That's always the case. So that's it. So basically, you had to realize that it's a vertical line when I say perpendicular to the x-axis. Yeah, so it's a negative reciprocal. So 2 and negative 1/2.
Passes through the point 3, 8, perpendicular to 2 x minus 1.
Okay, so that kind of answers both your questions. So passes through 3, 8 and perpendicular to what? All right. So in order for us to find the equation of a line, we're always looking for two pieces of information, slope and a point. Is that right? We have a point, 3, 8. We don't have a slope. It's not given to us, but we can find it, right? And the way we're going to find the slope of our line, we're first going to find the slope of this reference line. Okay? How would you find the slope of that line in the box? Solve for y. That's right. So you're going to take that 2x minus 4y plus 3 equals 0. Solve for y. And all you really care about the coefficient in front of x. You don't care about the y-intercept. So if you solve for y, we can do this. We can add 4y to both sides. Is that right? And then divide both sides by 4. So y equals, 1/2 x plus, I no longer care, but just in case it's 3/4, but it's really relevant to the solution of this problem. The y-intercept of my reference line makes no difference. All I care is that the slope of this line is 1/2. Is that okay? That's right. So since the line that we're looking for is perpendicular to this one, so in order to find the slope, you take the reciprocal and you change the sign and you get -2, right? So this is the slope of the line that was given to us. So the slope of our line, what was that? Yeah, just divide both sides by 4 here. So our slope is -2. The point is 3, 8. So the rest is simple. We'll just set it up. I like using this formula to set this up. You need to know your equations of the lines and all that. So plug everything in. Y minus 8 equals -2 times x minus 3. And then just simplify that. Add 8 to both sides. Y equals -2x plus 14. Yeah.
It has to be, like, you couldn't do 8 minus y, like this.
Yeah, you can, I think, but it's just don't. Just go get all messed up. Can somebody smack him? You're in charge of smacking right now. Didn't we just discuss that? Who wants to answer that question? He asked me why is 1 half, the other one is -2. What? All right, good. I'm picking on Shaq today. He made a mistake of showing up after missing I don't know how many classes. That's it. Yeah, that's good. Payback. Yes. No, I don't think so. You can ask me. All right.
So, try to find the domain of the square root of 9 minus 3.
Less than or greater than 9? Yeah. So yeah, you just checked your answer. Because again, remember, when you're dealing with those square roots, you just set it to greater than or equal to 0, whatever's under the radical. And you solve, you flip your sign, so good. Question, stretching? All right.
How would you? Okay, so this question is find the quadratic function that satisfies the following coordinates. X-intercept.
Oh, that's a good one. Let's talk about that one. I like that question. That is a hard question. What is that? Well, let me read that. So, this is a very good question. Find the quadratic function that satisfies, oh yeah, that's nasty, satisfies the following. Well, no. No. But, well, you're being tested if you want to, yeah, exactly. So you totally know how to do this problem. We just not necessarily talked about it. Following conditions. X intercepts are x equals 2, x equals -3, and passes through -2 and a 5. Okay? Well, that's a quadratic function, so yes. The graph is a parabola. So you have all pieces that you need in order to solve this question. You just need to kind of put it together and think a little, right? Which is a requirement if you want to get an A on a test. So, I mean, you can still get an A if you totally miss that question. You've got to get everything else right, which we all talked about in greater detail. But here we need to get a little bit creative. So first of all, we know this much. That our function looks something like that, right? Because it does say a quadratic function. Do you agree with that? All right. Now, it also says that our function has these two x-intercepts, right? Now, what are the x-intercepts? How do you find x-intercepts? It crosses the x-axis, good, but how do you find x-intercepts? So you said y equals 0 and you solve for x, right? So if I actually do this, ax squared plus bx plus c and set it equal to 0, and I solve for x, I should get x equals 2 and x equals -3. I'm kind of trying to think backwards, right? So now think about this. If you were able to factor this equation, think about factoring. If one solution is x equals 2, x minus 2 has to be a factor, right? In order for x equals 2 to be one of the solutions, x minus 2 has to be a factor, x plus 3 has to be a factor, right? Now, if I multiply this by 4, will that change my x-intercepts? No, right? It'll still give you 2 and negative 3. If I multiply this by 14, it will not change my x-intercept. So all I can say that at this point, my function is really any number times x minus 2 times x plus 3. Because whatever that, yeah, so that a could be any real number, but it will still produce x equals 2, hang on, so it will still produce x equals 2 and x equals negative 3 as my x-intercept, while the number in front doesn't really affect the x-intercepts. Now, Shaq, you were saying something. But now that's what this comes in. This piece that our graph passes through that point. Yeah, you plug it in for x and y, and then you solve for a. Okay? So yeah, you 5 equals a. Oh, I don't know. Could be 1. Right? So, but I can find it now by plugging negative 2 for x and 5 for y, and then I can solve for a, and I'll get my function. So 5 equals a times, this is negative 4, and this is what? Positive 1? So my equation is 5 equals negative 4a. So what is a? Yeah, so negative 5 over 4. So then my equation is, my function is this. It's negative 5/4, and then x minus 2, and x plus 3. Whatever that is, if you FOIL, doesn't matter. That's the function. Oh, well, that was the y value of the point that was given to me, right? You see that point? So I plugged in 5 for y and negative 2 for x. So that's the answer. Yeah, you don't need to FOIL this, so there's going to be a whole bunch of ugly fractions. But this function right there will give you a parabola that hits the x-axis at positive 2 and at negative 3, and it will go through the point negative 2 comma 5. That makes sense? So we kind of, but yes, this is a little sneaky. We had to think backwards. We had to go backwards from the solutions to the equation, realize that those are the factors, and then solve for the coefficient. Oh, yeah, I'm totally fine with that. You don't have to FOIL this. So yeah, you expect one question, at least one question on the test where you might go, what? But you should be able, you have all the skills to do it. And if you just leave it blank, you'll still probably going to get an A. It's not going to worth a whole lot of points. Do you want to? We'll define a lot. 1? I'll give you 1. What? Yeah, probably less than 5. Yeah. What? Yeah, well, what is the word problem?
It's the one with the fence in the river.
Is that the one with the fence in the river? I don't think, I'm not going to do the fence in the river. Was there another one? Is there only one? Oh, it's fence in the river. We've done it. Is that it? Well, you can check the notes and the few videos that have that problem. But yeah, yeah. Oh yeah, this is your homework problem. Yeah, it's. I'm about same numbers. We like I know we were in feet. That one is in meters. Yeah. So odd even. No, 21 is not the one I was looking at. All right. So do you remember how to do odd even though? Like 19? Yeah, review that. So 3x minus 1 if x is less than or equal to negative 2, 4. Okay. If x is between that, and x squared if x is greater than 2. Oh, actually, I'm not even close to being done. No. So we need to evaluate this thing. So that will test your knowledge of, well, whether you understand how piecewise functions work. And we remember how we just have to use our definition of a piecewise function as kind of a filter. So when you look at f of negative 3, that means the value of the variable is negative 3. So which one of those three pieces? Right. Negative 3 is less than negative 2, so it's the first part. So 3 times negative 3 minus 1 looks like negative 10. Right? You agree with that? Now, how about negative 2? Where's that one going to go? Same thing. Still goes on the top one because negative 2 satisfies that inequality. So it's 3 times negative 2 minus 1 looks like negative 7. Now, how about negative 1.43? Where's that going to go? Yeah, so it's 4 because it's a constant. It's always 4. They're in the middle, so you get 4. How about f of 0? Still 4. How about f of 2? Still 4. Because all those negative 1.43, 0, and 2 satisfy the middle inequality. So that function is constant, always equals 4. How about 9, right? So it's 3 squared equals 9.
The next part is to sketch.
Right, the next part is to sketch the graph. By the way, you already know 6 points on that graph, right? I mean, you should use that. I mean, you know those ordered pairs already. You can actually almost cheat a little bit. You know that the graph goes through negative 3, negative 10, right? You know that's the point on the graph. Use it. You know that negative 2, negative 7, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So negative 7 somewhere here, right? You know those points. And you know something going on with a 4. You have a bunch of points here. And then you have a 3 and a 9. So you know those points at least. I'm not saying that's all you need, but all you know that it's going to go on a straight line first. That first part, 3x minus 1, is a straight line, right? Slope is 3. How far is it going to go? Where is it going to stop? At negative 2, right? So it actually stops right here. So I extended it a little too far. So it has a line that goes all the way there and then just stops here. And I'm making a big fat dot because that point is on that line. Then it makes a jump. Well, because it says right there it stops at negative 2, right? And so then it makes a jump. It turns into a constant. Yeah, that's a negative 1.43. So then you have a straight line between negative 2 and a positive 2, right? I mean, you have a constant between negative 2 and a positive 2. And what happens after positive 2? What is it going to turn into? When x passes that threshold of 2, what is your function? Over there, on the to the right of positive 2, what is your function going to turn into? Anyone? What is the function for x is greater than 2? x squared. And what is the graph of x squared? It's a parabola. But now the only thing is, so yeah, it's some kind of a parabola, but what happens with that parabola? I want to know how high is it. If I actually take a 2 and I plug it in my parabola, where is it going to start? If I take 2 and I plug it into x squared, what do I get? 4. So it actually starts at this point, doesn't it? This point, 2, 4. And from there on, it will continue going like a parabola.
Where did the 4 come from?
Well, what is 2 squared? 4. So technically it should have a circle, because it's 2 is not part of it, but 2 also gave us a 4 on both ends, so it actually connected. There. Because one end is included and the other end is not included. I don't know yet, but you should know the formula. What? Now, for those of you who are watching this video online right now and being live, if you type word puppy, I'll give you extra credit. No, you don't get extra credit. Anyone's typing? I don't know yet. Nobody's typing? All right. Yeah. All right, well, that was worth a try. That's how easy to earn extra credit.
Can we do some, what is it, absolute value?
Yeah. So what does that say?
We have to do absolute value with inequalities and without.
Well, yeah, you should be able to do equations and inequalities with absolute value. I can try. I don't know. I don't know whose question to answer right now. What was your question? I know they usually are. So, and you. Yeah, because there's the parabola only starts at +2 on the x-axis, right? That's the yeah. So there's something else going to the left of 2. Yeah. All right. So what? Which one? What does it say? Like that, right? Okay. This one's going to be a little tricky. Okay. That's what we did on Wednesday. Uh, well, didn't you watch the video in the last 5 days of Wednesday's class? What? Then you should come to class. Anyways, which case is that? Remember, we had case 1 and case 2. Because that's the important part. If you cannot distinguish between the cases, you won't be able to move on, because you have to find a way to drop the inequality. And it depending on which way the sign faces. If it's less than, it's one case. If it's greater than, it's the other case. So which case is that? Yeah, you don't want that, because then I'll have to make it extra hard. You see, there are 2 things you should never agree: open note test and a take-home test. Don't ever agree to take-home test. I know, so that's what I'm thinking about when I'm making that test up. So you can Google things, you can call a friend, you can call your physicist uncle. You know, I have to make it a fun test then for you and your uncle. So, case 1. So how do we drop the inequality if it's case 1? So put everything in the middle, and then it's from -5 less than or equal to +5. Right? So that was the case 1. Right? So that's the case 1. So we kind of get 1 inequality. Well, now solve for x. What do? -1 all the way across. That gives us -6 less than or equal to -2x less than or equal to 4. That's right. Have to flip the signs. Now this is where it gets a little funky, but not that funky. So divide everything by -2. When we solve inequalities and divide by negative numbers, so all the inequality signs kind of flip, right? But really, it still reads, from, it's equivalent saying it's from -2 to 3. So x is still between -2 and +3, right? Yeah, so if you sketch this, so this is -2, and this is +3, and x is, right, greater than -2 and less than +3, so it's equivalent to the second statement. So this is that. Well, actually, so yeah, on the paper test, either you do the dots or the brackets. I don't care. They're both correct. On the, on your homework, you had to use the brackets too. But usually those are multiple choice questions on the homework.
Um,
Go ahead.
so the thing that's hard about practicing, like the fence one, is that it's not in any of the homework.
Yeah,
I
but
don't know what it is.
but it's on like 3 videos. Go ahead.
For every like inequality absolute value problem, right? You just set it like say 1 minus 2x is less than or equal to 5, and then 1 minus 2x is greater than or equal to 5.
You can.
That makes sense.
Yeah, but then you have to find the intersection of 2 sets because you're going to have 2 lines going in opposite direction, and they'll overlap. So the overlap will be the solution. But this one gives you the overlap for free. You don't have to think about this. Because yes, it does say everything greater than -2, so that's that set. And this says everything less than 3, so that's that set. And if you do it as separate 2, that's what you end up with, and you'll take the intersection. Yeah, well, you know the graph of absolute value of x, right? Because that's asking you to sketch the graph, right? And where do you go? Is +1 inside the absolute value or outside the absolute value? So what do you shift if it's inside? 1 to the left, right? So then can you state the range of that function if you shift 1 to the left? What is the range of that function? Greater than 0, right? Yeah, from 0 to infinity, including 0. So, you want to do the fence question? Fence? So what is the story on the fence? Well, you didn't laugh at the joke. That's why he's having problems with the fence problem, because you don't get how to maximize stuff. You just build a fence around yourself and you claim to be outside. That's the solution to the problem. Jesus Christ, when are you going to get that?
400 meters fencing.
All right, so you have 4,000 meters. Wow, that's a lot of fencing. That's a 4 kilometers worth of fencing. That's a, and you don't build along the river? That's a. All right. How many regions? Is it just one? Oh, just one? Is that it? You just have to do that? No subdivisions? Oh, this. Well, that's why it's even easier, right? So you're trying to maximize the area. What is the area of this region? X times y, right?
So what I have so far is about y minus 2x times x equals 4,000. Is that right?
No, because you don't want to have more than one. No. Well, do you all agree that the area is x times y? Right. Yeah. Because we know then in order to, first of all, in order to maximize the area, we better use the entire fencing, right? We're not going to having 4,000 meters of fencing and only use 2,000 and build the maximum area. Okay, so we're going to use all of it. So therefore, x plus y equals 4,000. That has to happen. Otherwise, you're not maximizing anything. So that's 2x plus y equals 4,000. So therefore, y equals 4,000 minus 2x, right? So you take that expression and you plug it in for y. So this way, you're going to end up with that, right? Which is a function of x, a of x equals, if you distribute x, it's negative 2x squared plus 4,000x. So that's the function. What? Are you okay how we got the function? All right, well, how do you find the maximum then? What are you looking for? That's an upside down parabola, right? So which point on that upside down parabola gives you the maximum value? No, we just talked about it. Like, what am I looking for? The vertex. How do you find the vertex of a parabola? You told me that like an hour ago. Negative b over 2a, right? So you need to find the vertex. So
I was like trying to find where.
So you're trying to find the vertex to see what the maximum.
yeah. So the vertex, so I'm getting the x value, right? So it's negative 4,000 over 2 times negative 2. So it looks like 1,000, right? By the way, what was the question? What are the dimensions or what is the maximum area? All right, so x has to be 1,000. Are we okay with that? So to find the maximum area, you plug 1,000 into your area and you'll get 1,000. It's easier to plug it in here when it's factored. 1,000 times 4,000 minus 2 times 1,000. So it looks like you're going to end up with 2 million square meters of area. I think you were in the bathroom for that time, but over there, you add all. Oh, there we go then. You add all the sides. It should be 4,000. So you get 2x plus y should equal 4,000. So you solve for y and you replace that y with 4,000 minus 2x. So that's that.
So why is it meters squared?
That's the area. But yeah, every time when I ask you to find the maximum or the minimum, you're looking for the vertex. Okay? You will be somehow given a quadratic. Okay? It will come out to be a quadratic because you only know how to maximize quadratics. Yeah, so the y value would be the actual maximum minimum value. The x value would be the location. So if I just ask you what are the dimensions that produce the maximum area, okay, you would say, all right, well, x has to be 1,000. Now, what is y if x is 1,000? So you go here, okay, if x is 1,000, then y would be 2,000. So 1,000 by 2,000 produces the maximum area, or 2 million square meters. That's irrelevant. You can compute that any way you like it. You can plug it in here or in there. Yeah, or just, this is 2,000, this little parenthesis. It's 4,000 minus 2,000. So it's 2,000 times 1,000. That's 2 million. Well, yeah, 3 including the final. Substantial. Well, definitely the final. But yeah, I think your class is out of 1,000 points. So this test will be like 200 points. So it's 200, 200, and the final is 300. And then all your... No, the quizzes count for 300 total. So a third of your grade is just sitting on the couch at home. Yeah. All right. Well,